Okay, children, today we will start with a question. The question reads, find the area, length of the arc of the sector if a sector is cut from a circle of radius 21 centimeter and sector angle of 150 degree. Let us analyze the question. Okay. Here there is a circle of radius 21 centimeter. From this circle they have cut a sector. Okay. Sector OAB they have cut. Okay. And the sector angle is 150 degree. And they have asked us what is the area of this sector. Okay. And what is the length of the arc AB. Okay. So children, here what they have given is radius of the sector is 21 centimeter and sector angle is 150 degree and the length of the arc we have to find out and area of the sector with sector angle 150 degree we have to find out. Okay. This is the required sector. Its area is to be found and this is the length of the arc of the sector. We have to find its length. Let us find the area of the sector first. We have the formula area of the sector is equal to 5r square by 360 degree into theta. Means for 360 degree central angle 5r square is the area. And for theta degree, how much is the area? Okay. So, 5r square by 360, here theta is 150 degree. Now, 0, 0 will get cancelled. Okay. 3 5s are and 3 12s are get cancelled. Therefore, 5 into 5r square is 5r square upon 12. So, 5 into 5 means 22 by 7. And this 12 by 1 when comes up, it becomes 1 by 12 into this radius square is 21 centimeter square. Okay. So, 5 into 22 by 7 into 1 by 12 into 21 into 21. Okay. See here children, 7 1s are, 7 3s are get cancelled. Then 3 1s are and 3 4s are will get cancelled. Okay. 3 4s are 12, 3 1s are 3. Right. And then here 2 2s are, 2 11s are get cancelled. Right. So, in the numerator 5 into 11 into 1 into 1 into 21. So, 5 into 11 then 1 into 21 and divided by 2. Okay. Now, the product of this is 1155 upon 2 centimeter square. If it is converted into decimal expansion, then it is 577.5 centimeter square. Therefore, area of the sector whose radius is r and sector angle is 150 degree is 577.5 centimeter square. Okay. Now, let us find the length of the arc of the sector. Okay. Means we should find the length AB, that is arc of the sector. We have the formula here. The length of the arc is equal to 2 5r upon 360 into theta. It means for 360 degree sector angle, the length of the arc is 2 5r. Means one full circle. But for theta degree sector angle, how much is the length of the arc? That is, for this much sector angle, this much is the length of the arc. For this much sector angle, how much is the length of the arc? Let me substitute the values. 2 5r upon 360 degree into theta is 150 degree. Okay. 0 and 0 will get cancelled here. And then 3 5s are and 3 12s are get cancelled. Then 2 1s are, 2 6 are will get cancelled. Now 5 into 5r is 5 5r upon 6. So children, 5 by 6 5r. 5 by 6 into 5 means 22 by 7. Okay. And this radius is 21 centimeter because the radius of the sector is 21 centimeter. I have put 21 centimeter, right? Now you see, 7 ones are, 7 threes are, then 3 ones are, and here 3 twos are will get cancelled, right? And we have 5 into 11, okay? 5 11s are 55. Therefore, 55 centimeter is the length of the arc of the sector for sector angle 150 degree. Okay. So children, here we have learnt that if a sector of sector angle 150 degree and radius 21 centimeter is cut out from a circle of radius 21 centimeter, its area is 577.5 centimeter square, and its length of the arc, the length of the arc is 55 centimeter. Okay. Let us see one more example. Okay. Example number 2. In the figures are shown sectors of 2 consecutive circles of radius 7 centimeter and 3.5 centimeter respectively. Find the area of the shaded region. Okay. Let us analyze this question. Right. The given figure is shown below or it is drawn below. Look here children. Actually here with radius OB there is one circle, and with radius OC there is another circle. Means both the circles have same center and different radii, but they are called consecutive circles. Means they are continuous circles. One is with radius OC and another is with radius OB, right? But from those 2 consecutive circles we have cut the sectors. Okay, sector OBA and sector OCD are the 2 sectors cut from the 2 consecutive circles. Here the sector angle is 30 degree and the radius of the bigger circle or bigger sector is 7 centimeter and the radius of the smaller circle or smaller sector is 3.5 centimeter. Okay, and this is the shaded region, and we have been asked to find out the area of this shaded region. Okay, look here children. Here the theta is 30 degree. I take capital R is equal to OB, that is 7 centimeter. Means the radius of the bigger sector, I take it as R is equal to 7 centimeter, and I take OD or OC is equal to small radius R. Small r is equal to OD, and that is equal to 3.5 centimeter. Okay. So this OD is the radius of the smaller sector and OB is the radius of the larger sector. Okay. If you would like to find out the area of this shaded region, what should be done? Find the area of OBA sector and minus the area of OCD sector. Okay. Then you will get only shaded region area. So children, here area of the shaded region is equal to area of sector OBA, okay, area of sector OBA minus area of sector OCD minus area of sector OCD, right? So what is the formula? We know that area of the sector is found by, for 360 degree, phi r square is the area. For theta, how much is the area? Okay, minus area of sector OCD. Sector OCD is, for 360 degree, phi r square is the area, and for theta degree, how much is the area? Okay, here I have taken capital R for larger circle and smaller r for smaller circle. Okay, so see here children, it is phi r square by 360 into theta minus phi small r square by 360 into theta. Okay, you will observe that phi 360 and theta are common in both the terms. Okay, therefore this phi 360 theta is taken out and inside r square minus r square remains. Okay, so capital R square minus small r square into 5 into theta upon 360. Let me substitute the values. The capital R is 7 square minus small r is 3.5 the whole square into 5 is 22 by 7, theta is 30 into 1 upon 360. Okay, this is 360, this is nothing but 360 by 1. If it is taken up, it becomes 1 by 360. Okay, so when we cancel, 0, 0 will get cancelled. Then 3 1s are, 3 12s are. Okay, then 2 6 are, 2 11s are. Right? And so children, here we get 7 square minus 3.5 the whole square. It is nothing but a square minus b square identity. So I can write a plus b into a minus b. So it is 7 plus 3.5 into 7 minus 3.5 into, here 11 ones are 11 and 6 sevens are 42. So it is 7 plus 3.5 is 10.5 and 7 minus 3.5 is 3.5 into 11 by 42. 10.5 means it is 100 by 5 upon 10 into 3.5 means 35 by 10 into 11 by 42. Right? See here, if we cancel the numbers here, ultimately we get 11 sevens are 77, 2 2s are 4 and 4 2s are 8. Therefore 77 upon 8 centimeter square is the area of this shaded region. But you can write it in decimal expansion as 9.625 centimeter square. Therefore, area of the shaded region is 9.625 centimeter square. Okay, the area of the shaded region is 9.625 centimeter square, means we can place 9.625 1 centimeter squares inside this shaded region. Okay, hope you understood this question. Let us consider one more example. It is application level. The minute hand of a clock is 10 centimeter long. Find the area on the face of the clock described or swept by the minute hand between 9 a.m. and 9:35 a.m. Now look at the face of the clock. Okay, when the time is 9 o'clock, that time the hour hand points 9 and the minute hand points 12. Let us see the face of the clock. Okay, here this is hour hand and this is the minute hand or minute hand. Now the time is 9 o'clock. When the time passes from 9 a.m. to 9:35 a.m., let us see how the sector is formed and sector angle increases. Okay, see here. Now it is 9:05. See the sector angle. Then it is 9:10. Look at the sector angle. The sector angle increased. Okay. Now it is 9:15. Look at the sector angle. Right. And then 9:15. Okay. Now it is 9:20. Look at the sector angle. It is increasing. And now it is 9:25. Look at the sector angle. Okay. And now the time is 9:30 minutes. Look at the sector angle. Sector angle is exactly here 180 degree. Okay. Now if the minute hand comes to number 7, it means it has moved or swept 35 minutes. Okay, the minute hand has moved from number 12 to number 7, means it has moved up to 35 minutes. That time, children, see here, this is the sector formed by the sweeping of the minute hand from 9 a.m. to 9:35 a.m. and this area we have to find out. Okay, this is the area swept by the minute hand from 9 a.m. to 9:35 a.m. Okay, and this is the length of the arc and this is the sector angle. Okay, they have given that the length of this minute hand is 10 centimeter. Okay, so until and unless we know the central angle or sector angle here, we will not be able to find the area swept by the minute hand from 9 a.m. to 9:35 a.m. Okay, let us calculate the sector angle of the sector. See here, this is the face of the clock at 9 a.m. and this is the face of the clock at 9:35 a.m. See here, this is hour hand and this is minute hand at 9 o'clock, and at 9:30 a.m. the position of hour hand is here and a minute hand or minute hand will have moved from number 12 to number 7. Therefore, this is the sector formed by the moment of the minute hand whose length is 10 centimeter. Okay, from 12 to number 7 means 35 minutes, and that time this is the central angle formed. Okay, let us find the central angle of this sector and then find the area of the sector. Let us analyze the question. The time between 9 a.m. and 9:35 a.m. is 35 minutes. Okay, now the angle described by the minute hand in 1 hour means in 60 minutes it is 360 degree. That is, when this minute hand moves or revolves one complete round, the sector angle is 360 degree. But when the minute hand moves for 35 minutes, okay, how much is the sector angle? Okay, that is what we have to calculate. See here. So children, the angle described by the minute hand in 35 minutes is 360 by 60 into 35. Means for 60 minutes it makes 360 degree sector angle. But for 35 minutes, how much sector angle it makes? It makes 210 degree. Therefore, the sector angle is 210 degree. See here, the length of the minute hand is 10 centimeter and that is equal to radius. Radius equal to 10 centimeter. Look at the dial here. This is length of the minute hand, 10 centimeter, and of course this is the radius of the sector. See here, the length of the minute hand whose length is 10 centimeter and this is equal to radius. But when it rotates from 12 to 7, that time it is the sector angle formed is how much? 210 degree. Okay, look at this. This is the sector angle for 35 minutes. Okay, and it is 210 degree. Now we know the radius is 10 centimeter and sector angle is 210 degree. Now we can calculate the area swept by the minute hand or minute hand of length 10 centimeter in moving from 9 a.m. to 9:35 a.m. means by making 210 degree sector angle. Okay, let us calculate the area. So children, the radius of the circle described by the minute hand is r and that is equal to 10 centimeter. Therefore, area on the face of the clock described or swept by the minute hand is theta by 360 into phi r square. That is, for 360 degree central angle, phi r square will be the area. And for theta degree, how much will be the area? Theta is 210 degree. 210 by 360 into phi is 22 by 7. Radius is 10 square. And after the simplification, I will get 550 upon 3 centimeter square. Okay? But when expressed in decimal expansion, it is 183.3 centimeter square. Okay? This is how we were able to find the area swept by the minute hand of the dial of the clock when it moves from 9 a.m. to 9:35 a.m. Okay? Let us take one more example which is very interesting. The perimeter of a sector of a circle of radius 5.7 centimeter is 27.2 centimeter. Find the area of the sector. Okay? Let us analyze the problem here. Right? Here, this ACBO is the sector and its perimeter is 27.2 centimeter. Means here OACBO is the required sector. Its perimeter has been given, that is OA plus AB plus BO. Length is how much? 27.2 centimeter. And radius of this sector is 5.7 centimeter. Okay? And the thing asked is find the area of this sector. To find the area of the sector, I need sector angle. But sector angle is not there. I have to calculate the sector angle. Right? See here. What do you mean by perimeter of the sector? Perimeter of the sector means one full round length of the sector. That is OA radius plus AB arc plus BO radius. Right? Makes the sector. The perimeter of the sector. Here, radius is 5.7 centimeter and sector angle I have to find, and I have to also find the length of the arc ACB. This is the length of the arc ACB I have to find. Let me see how it can be done. Let OAB be the sector with perimeter 27.2 centimeter. Then we have OA plus OB plus arc ACB is equal to 27.2 centimeter. Here OA is radius 5.7 centimeter, OB is radius 5.7 centimeter, and arc ACB I don't know. But they have given that the perimeter of the sector is 27.2 centimeter. Therefore 5.7 plus 5.7 is 11.4 centimeter. If this 11.4 is sent this side, it becomes 27.2 minus 11.4 is equal to 15.8 centimeter. Thus, arc length ACB is 15.8 centimeter. Okay, we have the formula length of the arc. Okay, for 360 degree, the length of the arc is 2 phi r, and for theta degree, how much is the length of the arc? We have this formula. So, we know that the length of the arc is already 15.8 centimeter. Therefore, length is equal to 15.8 centimeter. And this is equal to what? For 360 degree, 2 phi r is the length. Okay. And for theta degree, how much is the length? The length is 15.8 centimeter. Therefore, here theta is the only unknown thing. So, let us transpose all these things this side. It becomes theta by 360 into 2 into 22 by 7, radius is 5.7. Therefore, on transposition we have theta is equal to 15.8 into 360 into 7 upon 2 into 22 into 5.7. Okay. If you simplify this, you will get 150.758 degree. That is 158.75 degree is the sector angle here. Okay. But that is the sector angle 158.75 degree. But area of the sector I have to calculate. Therefore, area of the sector formula is 360 degree central angle, phi r square is the area, and for theta degree, how much is the area? Okay. Look at me here, children. Theta means 15.8 into 360 into 7 upon 2 into 22 into 5.7. Therefore, for theta, we put 15.8 into 360 into 7 upon 2 into 22 into 5.7 means this factor. For theta, I put this thing, right? Then what I have is this divided by 360. This 360 comes here into phi r square. Phi is 22 by 7 into radius square. This is 5.7 the whole square, right? After the simplification, you will have the area of the sector as 45.03 centimeters square. Therefore, children, this is how we became able to find the area of the sector as 45.03 centimeters square because we found the sector angle theta here. Okay, and similarly we found the length of the arc, okay, as 15.8 centimeter. Is it clear? So children, today we learned 3-4 problems related to the area of the sector. Okay, hope you have learnt about the questions what we have discussed today, and in my next classes I will take the different types of problems.